To solve an absolute value inequality, the first thing that you want to do is isolate the absolute value. For this particular problem, that means I'm going to have to add 2 to both sides, and then I'll have the absolute value of 3x minus 2 is greater than 5. Before I go any further, I want to think about what this means. If I forget about the fact that I've got 3x minus 2 inside of the absolute value, and just say that's some number. I've got the absolute value of some number, and it must be bigger than 5. Graphically, if I think of this, what that means is if I'm looking for numbers whose absolute value is bigger than 5, I need numbers that are bigger than 5, or I need numbers that are less than negative 5. So this idea is going to tell me how I can break up the absolute value inequality into 2 regular inequalities without the absolute value. So same what I just said a second ago over here, I need to have values of some number that are greater than 5, or that number must be less than negative 5. When I solve each of these inequalities separately, throw in the union, I'll have the solution to the original inequality. So over here I'm going to add 2 to both sides. I'll have 3x is greater than 7, or x is greater than 7/3. On the right-hand side, adding 2 to both sides, 3x would be less than negative 3, or x is less than negative 1. So I have 2 inequalities. It's a compound inequality. X is less than negative 1 in interval notation goes from negative infinity to negative 1. X is greater than 7/3 goes from 7/3 to infinity. And when I connect these two using the union symbol for or, I'll have negative infinity to negative 1, union or 7/3 to infinity.